Hi again guys. So today we'll be looking at function notation. So I've got some actual UK or past questions we'll go through which just uses our function notation, but we're just going to talk about this one here. Should be a nice short video. First off, let's just look at our normal function notation, which is this one here. Okay, so what this actually means is that this is the function of x. Okay, so this is the function of x, okay, and this side here is what we do to our input. So a nice easy way that I've always explained it is that this is our f function, so f of x, and that just gives us a name, and we'll see that in another question in a moment. Our input is what's inside the brackets, what's inside the f function. So this is my input, and whatever you get out is your output. So you could say f of x is actually our complete output, because it creates, so we take an input, we do an operation, a function of it, which you might have done in year 7, and then you get yourself an output. So in this case, you can see that our function f is actually taking the x values and it's squaring them. Okay, so first off, we could look at that. So I'm going to show you a graph of this, is what you could see, and we'll show that on the next slide. So here you can see that I've actually graphed f of x, where f of x is x squared. So every time we have an input, we have squared that value, and we've plotted it on a graph. So an easiest way that you might ever see this is you might see the function f of x equals to x squared as y equals x squared. And we will be using this when we do inverse functions, but that's kind of the process. We're just so used to using it as algebra because that's how we teach it when we're doing graphing. Now, what this means is that you can use, we're going to use this notation. So we got f of x is equal to x squared. So let's say that if I want to find out f of 1 in this scenario. So here, this is the function f of x. So therefore, if I have f of 1, what I want to do is wherever I see an x, I want to substitute 1 into. Okay, because we're mapping this one using this function here, which would be 1 squared, which is 1. If I had f of negative 2, I would replace my x value, because my input is now negative 2. Negative 2 squared, which is negative 2 times negative 2, which is 4. Okay, just like you've normally done, we're just substituting in, but we're actually mapping this using this function. And you can see here that 1 is 1, 2, negative 2 is, sorry, that's negative 1, negative 2 is 4, and so on and so forth. And that is honestly it for functions. It is nice and simple, but it's just to remember, if you're told of this, okay, this is your function of x, where this is your input, and the whole thing is your output. So another thing you could do is if you wanted to find out when f of x equals to 16. So when does the output of this function equal 16, what would the input have to be? So what we could do is we could look at 16, go across, find our function, and we could go down, and here you'll notice we have two potential values. We have 4 or negative 4. And this is, and you should have done some relation so far, but just keep this in mind. Another way you could write this without doing it on a graph is, you know the function of x is x squared, so you know that x squared needs to be 16. Therefore, if we square root both sides, x could be either plus or minus the square root of 16, which is 4. Very, very simply, just remembering that f of x is our output and our input is the x inside the brackets. Another way you might be able to see this is you might see this function written slightly different, which is written like this, just in case it comes up. F the function with x as the input is mapped using x squared. So this is just another way you could write it. So f is the function with the input x using the mapping x squared. Okay, and all this really means is this here. Okay, might not come across this in your spec, but it is good to know. So here, what we're going to do, it tells us our function, f of x, that's how we say that, so f of x, that's our name of our function, is equal to cx plus d. So they're unknown of our coefficient x and our unknown constant here. But what it does tell us is it gives us two pieces of information. It tells us when our input is 4, our output is 7. Okay, so that's how we could write that. So instead of doing this here, so when our input is 4, so I'd replace my x with 4, the output of this equals 7. Okay, because all I've done is this here. I've replaced my 4 with x and my 7 with the actual output, your function of x. And the same for f of 10 equals 22. 22 is our output, and it's equal when we have an input of 10, so we replace, I made a mistake here, let's just do this again. So what we're going to do now is we're going to use our notation here to try and find the unknown function. So what you can see is your f of x is, we've got this mapping which is cx plus d. But if you have a look underneath, it gives us some information. It tells us when our input is 4, our output here is going to be 7. So if I was to rewrite this so we have a nice over here, when our input's 4, so we're going to replace this x with 4, so we have 4 times c, which I can just write this, plus d. Our output, this f of x, has to be 7, so that's this one here. And when our input is 10, our output is 22. So that means 22 equals 10c plus d. Now what you'll notice is we have simultaneous equations where these coefficients are the same. So if we subtract the top equation from the bottom equation, you're left with 15 on this side. You'll have 10c minus 4c is 6c, and our d's will cancel. And therefore our c will be equal to, and it's not a nice number, but 2.5. Let's just leave it as 2.5. Okay, or we could leave that as 5 over 2 if we want to leave it as a fraction, which we might be useful for the other one. So once we have this, we can then go back to one of ours. I'm going to pick of our equations. I'm going to pick equation 1, and we know our c value, so we could say 7 equals 4 times 5 over 2 times 5 over 2, sorry for that, plus d. Therefore we could do a bit of cancelling. So we have 7 equals 10 plus d, which means d is going to be equal to negative 3. And because we're good mathematicians, we're just going to check with our last equation. 10 times 5 over 2 minus 3. So we've got 22 equals, that becomes 5 there. 25 minus 3, which equals 22. So we've done the right thing. So just to recap, our function of x here, f of x, is equal to x squared. All that means is if I wanted to find out the output when x equals negative 3, instead of writing all this, I could just say f of negative 3, and then I could do my maths, which is in this case negative 3 squared, which is 9. So it's a faster way to write our substitution. Thank you so much. Have a great day.